Alright, so welcome everybody. We're now going to talk about our last subject for Unit 2, which is nomenclature, aka naming and writing compounds. So for each of the three bonds we talked about, and the three types of compounds, metallic, ionic, and covalent, we're going to talk about how to write the chemical formulas. So we're talking about things like, NaCl, what to name these, so how to, sodium chloride, and, so how to write the formula and how to know what to call them. Okay. So, like I said, three kinds. We can distinguish them by the type of atoms that are bonded in them. Okay, this is going to be a fairly dense lecture, and I don't want it to be too long, so I'm going to try to kind of just get through things quickly. Alright, the new thing that we're going to be mentioning here is polyatomic ions. You've maybe seen them before, but we're going to make them explicit in how to use them. Okay. So, metals, we've gone over this before. Metals are the simplest of all of these. If you need to write the chemical formula, in quotes, for a metal, you just write the elemental symbol of the metal, and that's it. So Ag for silver. And if you need to write the name, you just write the name, silver. Alright, no subscripts, no numbers, no nothing. So metals, very easy. Ionic compounds, okay, we've practiced writing the formulas a little bit, but there are two new things. One, actually naming them, and two, how to include polyatomic ions. Alright? So, polyatomic ions, speaking of, these are the 8 that you need to know in this class. Alright? And by know, I mean you should have them in your notes. And the main thing to know about them is how to write them, and this is how to write them, and also what their charge is. Okay? Some of them have charges of minus or plus 1. Okay, these are ions. They're made up of a bunch of different atoms, but they're the same thing as writing, chlorine -1, or, excuse me, or cadmium +2. It's the exact same thing, except it's just, writing out more letters. Okay, so associate the name and the formula, and know what charge they are, and remember to put them in parentheses, and it should not be any more complicated than writing ionic formulas with just normal elements. Okay, but we'll give examples. So, for writing for ionic compounds, okay, this is how to write the name. Okay, first you write the name of the first element or polyatomic ion. Then you write the name of the second element or polyatomic ion. And if it's an element, not a polyatomic ion, you change the ending of the element from, or ic or -ine to -ide. Okay, so classic example of sodium chloride, right? The first element is just sodium, and then you write the second one, which is chlorine. But because this is an element, not a polyatomic ion, we change that ending to be chloride. Okay. And then if it's a transition metal or intertransition metal, basically from that middle of the periodic table, you add a Roman numeral to indicate its charge. And there are two exceptions to this. Silver is always going to have a +1 charge, and zinc is always going to have a +2 charge. Okay, and the compound must be neutral. So, continuing with our sodium chloride here, we would just take these two and combine them together, and that is the name for NaCl. Okay? We will do more examples, but make sure you have this down. Alright, so here are the examples. NaCl, we already did it. It's sodium chloride. So, we got that. This one, all right, first element is potassium. Then the next element is sulfur. But remember, because it's an element and not a polyatomic ion, we don't end it in we end it in ide. Okay, so potassium sulfide. Next up, magnesium sulfate. So we go magnesium. And then, because it's a polyatomic ion, we just straight up write the name, no need to change the ending, and that's it. Then we've got manganese, and then we've got another polyatomic ion, hydroxide. And finally, lithium, we write this first one, and then we've got sulfur again, so it is once again sulfide. I forgot one thing. In this manganese one, right, manganese is a transition metal. And so in this case, because we've got two hydroxides and each hydroxide is -1, to balance this out, we need to put our Roman numeral in the middle. And so it'll be manganese 2 hydroxide. Okay? So, there's our answers. And remember, this Roman numeral in the middle is because manganese was a transition metal. Okay? It was in the middle of the periodic table. Alright. Writing ionic formulas, this is something we've done already. Okay, where we basically, you know, we had the charges, like we had cadmium 2+, and nitrogen 3-, and we did the crisscross. This is from 2 notes ago, basically. But this, you know, I'm just giving to you so you can look at it, fill in the notes, and have explicit instructions on how to write ionic formulas, even though this was already done in a previous notes. The most important thing that we haven't seen before is down here. If it's a polyatomic ion, so let's say instead of nitride, we have cadmium hydroxide, okay? That's -1, that's 2+, and since we're going to need to put a 2 down here, we just put her parentheses around it. It's cadmium hydroxide, like that. Okay? You do that for polyatomic ions and polyatomic ions only. Alright, on to covalent compounds. Covalent compounds, I think, are easier. Ionic compounds are probably the hardest ones. Remember, this is nonmetals and nonmetals. There's really only 2 steps. You say the first element and then the second element, and then you just add prefixes like the ones we have over here to say how many of them there are. Okay, so as an example, let's see, let's do the classic. H2O, alright, is water, right? But the actual sort of official technical name for it is, okay, you write out the first element, hydrogen, and then add the prefix if there's more than one. We can see there are 2 hydrogens, so this is dihydrogen, because we went up here and got the prefix for 2. And then we add the prefix and write the name of the second element, so this is oxygen, and there's only 1 of them, but we change the suffix to ide, so this is dihydrogen monoxide, where we went up and we got the mono prefix because there's only 1 oxygen. Okay? So, let's do a little bit of practice here. We've got sulfur. There's only 1 sulfur, so we don't need to add a prefix. So this is sulfur. And then we write the second one, but there are two of them, so we add a prefix, dioxide, right? Because it's not dioxygen, it's dioxide because it's the second element. All right. Then for this one, nitrogen, but we've got two of them, so we need dinitrogen. And then we've got oxide, but we've got four of them now, so we check over here. The prefix for 4 is tetra, so tetroxide. All right. Since oxygen is a little tricky because it starts with an O, and so it kind of combines with the vowels at the end of all of these. But if that were like sulfur, for example, it would be tetrasulfide. Okay, now let's keep going. Phosphorus, we've got 4 of them, so tetra phosphorus. Okay, long words. And then decoxide. Okay, because there are 10 of them. And then here, nitrogen, no prefix because it's just one. Dioxide. And then dinitrogen. And then 4 chlorines. Once again, that is tetrachloride. Okay, so there's some long words in here. The spellings, might be a little bit tricky, but if you follow these 2 rules, you'll always get it right, and I'm not going to count you off major points if you kind of, like if you called this, let's see, what's a good example? Decaoxide instead of decoxide. You can do either one. These slides might even have decaoxide on them. Don't worry about those little things. Just follow these first 2 rules. Don't worry specifically about where the letters do or don't go, and you'll do fine. All right, so let's see, we got sulfur dioxide, dinitrogen tetroxide, tetraphosphorus decoxide, nitrogen dioxide, and dinitrogen tetrachloride. Okay, so feel free to write down any of these examples in sort of the blank space on the bottom of this on your notes. There's sort of an extra half page there to write any of these examples. That's totally fine, and they should help you on the test, so feel free to write those. Okay, now we're writing covalent formulas. So basically what we were doing before, right, we had the formula and we needed the name. Now we're doing the reverse. What if I give you the name and you need to write the formula? Okay? It's basically the same thing, except you don't need to worry about the spelling and you don't need to worry about ending things in "ide" and stuff like that. You just write the first element. If there's a prefix, you sort of swap it back to the number and then add it as a subscript. Okay? And then you do the same thing for the second element. But keep in mind, we don't add subscripts when there's only one. Okay, so example for this is if I had dihydrogen monoxide, our water from earlier, okay, we write the symbol for the first element, hydrogen. If there's a prefix, add that number. There is, it's a 2 from the di. And then for the second element, we write the symbol. And then you add the prefix number as a subscript, but if it's mono, that means, which it is, that means there's only one of them, so we don't put anything there, and it's just H2O. Alright? So finally, do some practice with these. Okay, boron, trichloride, so it's chlorine, and there are 3 of them. Okay, dinitrogen, so that's N2. Monoxide, so just 1 oxygen. Dihydrogen, okay, I believe this is the example we just did, and 1 oxygen from monoxide. Carbon, no prefix, so just 1 carbon. Monoxide, just one O and no subscript because they're both 1. And then carbon dioxide is C, and then 2 oxygens. Okay, so if you're able to do the previous couple slides, these ones should be pretty easy for you, I would think. All right, and there's your answers. Okay, so we're obviously going to practice this. I know that was quite a lot, quite quickly, but yeah, congrats on finishing the final lecture of the 2nd unit, and I will see you in class.